Here's a problem from homework number 10. It says the accompanying table contains the results from experiments with a polygraph instrument. So sort of like a lie detector test. Find the probabilities of the events in parts A and B and answer the question, are these events unlikely? So let's start here with letter A. It says four of the test subjects are randomly selected with replacement, and they all had true negative test results. Okay, so what is the probability of that happening? So really what we're trying to find is the probability of a true negative. And because these are like ands, four of them, we have to think of them like four events. So times the probability of another true negative times the probability of another true negative times the probability of another true negative. And that's going to give us the probability that all four people would have true negative test results, meaning that the subject really did not lie, and the test results said that they didn't lie. The test result was negative. So I think with this column, what we're looking at right here, these 54 people right here. Well, we know the probability of any event is the number of ways that it can happen with a total number of outcomes. So in this case, the probability of 4 true negatives is going to equal to, I should have put that up here, probability of 4 true negatives equals, and that's this whole long line here. So the probability that the first one that we pick is a true negative, well, there's 54 people who had true negatives over how many people in this study? Well, if we use our calculators and we add up 54 plus the 6 plus the 30 plus the 15, you'll find that that equals 105 people total in this study. So we're going to have 105 people. Okay, times. Now this is saying with replacement. It's like that person goes back into the group and we randomly pick somebody again. So it's the same 54 people that will be true negatives, and it's the same 105 total. And in fact, this will happen 4 times because we're wondering if every single time we randomly choose a person who has tested negative and actually did not lie. So a true negative is what we call that. And I made a mistake right here, which I need to erase. I'm still learning this, so I think what I'm going to do is just cross this out and put a 5. All right, so another way of writing this, when you put it into the calculator, is you press your fraction button, put your 54 in the numerator, your 105 in the denominator, and you'll notice there's a little caret sign, and that means to the power of, and we are doing this 4 times. So this is to the power of 4. And when you do that, you will get here we go, 0.06995, and they're telling us to round it to 4 decimal places. So in this case, we would write 0.0700, or you can even just write 0.7 because the 4th spot is right here. But if we look to one to the right, we see that we have to round up, and that's going to just shift everything. So there's a 7% chance that if we choose 4 people with replacement, that they will all 4 be true negatives. All right, let's move on to part B. If you have any trouble with this on your calculator, be sure to come ask me in class. Let's try letter B here. We're going to do the same thing now. What's the probability that 4 of the test subjects are randomly selected without replacement? That they all had true negative test results. So again, we are talking about the probability of 4 true negatives, and that is going to equal this same formula. I'm not going to write it down again. I'm just going to start filling it in. So again, the chances of choosing the first person to be a true negative, well, there's 54 possible outcomes over a total possible outcomes of 105. 54 ways to get what we want. Okay, now this person is standing aside. Now we've already chosen one person. What's the probability that the next person we choose is also a true negative? We are not going to replace it. That means now there are only 53 true negatives left in the group out of a possible 104 people, right? Because one of the people has already been chosen. Now we have 2 people chosen, meaning that there are now 52 true negatives left in the group and 103 people total, times finally 51 over a possible 102. All right, I'm going to let you very carefully plug that into your calculator. Use your fraction button, and when you do that, you will then discover that your answer is 0.06615. So again, we round to the to 4 decimal places, which is right here. So that is going to equal 0.0662. So not a huge difference in the two percentages. It's just a slight difference because without replacement, your odds are decreasing a little bit. So because you don't have as many people each time. So hence ever so slightly difference. But then the question is, which I actually forgot to answer in the first part, but if we go back up here, it says, are these events unlikely? Are these events unlikely? So let's start with letter A. This event is about a 7%, and if we remember our 5% rule, because 7% is greater than 5%, we would say that this is not an unlikely event. Remember, we're thinking as statisticians here, not unlikely. And in fact, same thing here. We can say 7% of 5%, or we can also write it as a decimal. We see that 0.0662 is greater than our 0.05, 5% being that magic line where things go from likely to unlikely. But again, this is not going to be an unlikely event. Right? So give it a try.